Okay, everyone, we are doing today graphing of system of equations from Algebra 1 regions, and we're going to do our own graphing, as well as we're going to go over all of the model response answers to see why they were good and why the ones that weren't good, basically the reason for that. So we are having a 4-point question over here. This is number 31 from a year ago, June 2024. And in this question, we had to graph two different types of equations, the quadratic one, which is a parabola, and a linear one, which is a line, right? So when I'm doing this kind of problems, what I want to do is I want to graph the easier one first, which is a line, which is the second one over here. And then after that, we're going to graph the parabola. Okay, so let's go. So how do we graph a line? Graphing a line is based on two things. The y-intercept, which is the second number. If it's in y equals mx plus b form, make sure it is. And the slope. The slope is located in between equals and x, which is in front of the x. And in our case, it's technically y equals 1x minus 1. 1x is technically 1 over 1. Or 2 over 2 or 3 over 3. Doesn't really matter. What matters is that we are going to graph y-intercept first, which is negative 1. We're going to locate on y-axis, we're going to locate negative 1, which is here. I'm trying to do my best here. And then we're going to do 1 over 1. By 1 over 1, I mean 1 is going to be my rise and 1 is going to be my run. So I'm going to go up 1, 1 to the right, up 1, 1 to the right, up 1, 1 to the right, put a point. Up 1, 1 to the right, put a point. Up 1, 1 to the... Oh, you see where I'm going with this. And so is down. So we're going to connect all of these points and all the way up. And I'm going to try to do my best, but no promises here. It's actually not that good, but I'm trying. And all the way down there. Don't forget to put that equation on top of the line because, well, apparently they take away points if you don't. Okay? And this is it. Don't forget to put arrows also. If you don't put arrows in the end for a linear function, you also gonna be taking point. Look, if you have 2 point, like if you have a line, right, and you do this and you stop here, this is a mistake. You have to go through the points and put a point. And put an arrow. All right, so now the most fun part. And by that I mean the parabola. How are we going to do parabola? Well, the first thing that I'm going to do is that I'm going to see that the y-intercept of this parabola is -6, and I can just locate -6 and put it there. 1, 2, 3, 4, 5, 6. Oh my God! I'm going up.
This is a
I'm going up the yeah. That's what I said. That's why I said oh my God. Yeah. So we're going to graph the y-intercept and it's going to be -6. So 1, 2, 3, 4, 5, 6. Put a point. Now, how do we find all the other points? So there are a couple of ways of doing it. You can either find, like basically create a t-table and then just plug in all of the possible numbers here. Like let's say at 0 we have -6. But what if we have 1, 2, 3, 4, and 5? Like let's say we can put 1 here and then plug it into the parabola and get the answer. Well, I prefer personally getting the vertex first, the vertex of the parabola. The vertex of the parabola is this thing. How do we get the vertex? We get the vertex by doing negative b over 2a. And in this case, the b will be in the negative 3. So it's minus negative 3 over 2. And a is the number in front of the x squared, which if it's nothing, it's 1. So we get negative 3, so positive 3 over 2, which is 1.5. All right, a little unpleasant, but what can we do? And then in order to find so this is only the x coordinate of the parabola, of the vertex, so 1.5. Now where will be the y coordinate? The y coordinate will be, we'll find it after we're going to plug in the 1.5 in both of the x's of the equation. And in order to do that, oops, in order to do that, we can use a little extra screen here and plug it in. You're all gonna have like a graphing calculator, so you guys can just do it in a graphing calculator. So I'm going to do it in a regular calculator. Calculating. Okay. The answer is negative 8.25. Okay. Let's do it. 1.5 and negative, so this is negative 6. 1.5 is here. Negative 6, negative 7, negative 8.25. Whoa. It's not that obvious here. Okay. I guess we're going to have to do 1 also. We're going to have to do 2. And I don't think if we need to do anything else. Maybe we're going to have to do, okay, maybe we're going to have to do 3 and 4. Why not? All right. So what are we doing is that we're plugging in 1 into x, the one that's squared, and the one that has negative 3 in it. Guys, hold on 1 second, please. I'm back. So having space is a little problem over here, you know. I would love to do everything here on the same page, but it's impossible. So I guess we're just gonna have to do it like somewhere on the side. So 1 squared minus 3 times 1 minus 6. 1 minus 3 minus 6, negative 8. So 1 will have negative 8. 1, negative 8. It's here. Okay. Well, as you know, parabolas are symmetrical. That means that the 2 will actually be the same. And we can check that. 2 squared is 4, minus 3 times 2, which is 6, minus 6, which is also negative 8, as I said, is going to be 3, negative 8. I mean 2, negative 8. And now we can do 3, but actually we don't even have to. Look at this, guys. Since parabola is symmetrical at its vertex, 3 will have the coordinate negative 6. You can obviously also check that. And what it will be then? 3. 3 squared is 9, minus 9 is going to be 0, and then minus 6 is going to be negative 6. And I think, personally, that this is enough. That this is enough to graph a parabola. And it's going to be something like this. I mean, not perfect. Obviously on the test you're gonna have to do a little bit of a better job. You know what? Can we just get more points? Let's get more points, guys. Let's get also negative 1, negative 2. Let's get 4 also. I think that the coordinates of the intersection will be one of those. So 4 squared minus 3 times 4 minus 6 is going to be 16 minus 12 minus 6, which is 4 minus 6, which is negative 2. So it's going to be 4, negative 2. So it means that negative 1 will also have negative 2. And look at this. We already have our first intersection point. And then the other intersection will probably be somewhere like up there. Oh my god, that's like so bad. So the second intersection point is going to probably be like at a 5, maybe at the 6. So let's do a 5. So 5 will be 5 squared minus 15 minus 6. So 25 minus 15 minus 6, 10 minus 6, which is 4. All right, so it's going to be 5, 4. 5, 4, and there is the second one. So we know that we don't have, like, every time we won't be able to do perfect graphing, even though we really want to. So I guess getting more points will make more sense, right? So negative 1 had negative 2. We ended up not needing negative 2, but we did need the 5, which gave us the 4. Okay? We're gonna put the equation on top of that parabola. Maybe somehow we're gonna do like this: y equals x squared minus 3x minus 6, and state all coordinates of all solutions. There are 2 solutions, and the coordinates of the first solution is going to be negative 1, negative 2, and the second one will be 5, 4. Okay, this is it. Now we're going to go over the model response answers. Let's see. So they graphed the line all the way. That's good. Plugged in bunch of points too. I don't know how they got like all of them, but Somehow the graphing, like actually they did. And -1, -2, 5, 4. All correct. So here. So that's a good answer. Okay, we're moving on. This was a 4 out of 4 points. The next one, look at this. What do you notice? First of all, there are no arrows anywhere, right? And also there are no equations on top of the functions of the graphs. So wow, also 4. Broke a couple of rules. Yes, obviously got the right answers, but there are a couple of rules that usually some teachers can take points off for. All right, this one looks good. The equations are there. There's no work though, probably done on a calculator. And this is a 3. The student stated only one solution correctly. Oh, I didn't even notice. The location is correct, but it's not -2, 1 for no reason. It's -1, -2. I don't know. Like all of a sudden the student just forgot how to name the coordinates randomly. All right. Next one. No arrows. No function name on top of the parabola. -1, -2. And okay, look at this. The student made a graphing error, but not including arrows on the graph. Do you see that? No arrows on the graph. No arrows on the graph. And no points taken away. 1 point taken away. Like I said, depending on who's checking. All right. No functions on the graphs. Arrows, yes. No solutions. Just ignore it completely. All you had to do is just state the coordinates of the intersection. All right. Oof. Okay, what is that? 5, 4, yes. -1, -2, yes. Arrows, yes. Look at this graph. This person graphed all of the numbers on the whole XY plane. Look at this. 1, 2, 3, from 1 to 15 each way. Guys, that's like 60 numbers you have to write. 30 here and 30 here. That took a while. And why there is the, what is it, a 2-pointer? Why? 5, 4, -1, 2. Oh, forgot that it's -1, negative. Okay. The student make one graphing error at 413. -413, -413. Oh, misplaced it a little bit. Probably should have been here. And one coordinate pair was stated incorrectly. This one. Well, punishing someone for that irrelevant point, kind of harsh. Considering that all of the points are graphed correctly. The arrows are there. I don't know. That's probably like and circled the correct locations. So I don't know. I don't know if it deserves it too. Okay. Ooh, what is that? So this student thought that the first one is also a line, which is not. The first one is graphed correctly. The second one is obviously a parabola, so graphed incorrectly. Split everything in 5, 10, 15. Wow. I don't understand anyone who does like all of the points all the way. Like point, 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 point. That's crazy. So if when you look at this and you don't know that it's a parabola, that's probably you didn't do a really good job in your algebra 1 class. So I mean, still got one. One for graphing the first one, right? I guess. I guess. All right. Next one. Ooh. Ooh. Oh, just a straight horizontal line and nothing else. This guy took a chance. Didn't work though. Graph -1 correctly. It's here. But really, no slope, no nothing. No parabola at all. 0. Guys, look, every time I just want to give that advice to everyone. Every time you want to graph something and you don't know like what it is or how to graph it, just create a t-table, right? And start plugging in just a random number, not random obviously, like start from 0. Plug in 0 in both of the x's. Get the answer. Put it here. Graph it after. Like put it there. And then you can plug in 1, get the answer. 2, get the answer. 3, get the answer. Then plug in the negatives. -1, -2, -3 into both of the axes and see your answers, and it will graph it itself. You don't have to think about it. The graph will make, like, you will see the points. The points will appear in a certain pattern, and you're gonna have to like just connect that pattern, and that would be it, and that would be enough. And that would be enough. That's how I used to do it. Was that like when I didn't know how to do the vertex, how to do the like anything. I just plugged in, got the answer, and kept plugging in until I have like the whole picture. Yeah. All right.